Decentralize all the things. Decentralize all the things.
Hey there! Welcome to the Web3 Summit Decentralize Now podcast series, hosted by the Decentralize All The Things podcast network. This series features discussions about decentralization from the 2018 Web3 Summit held in Berlin, Germany. This is episode 13. In this episode, we sit in on a conversation about decentralized file storage and IPFS, which is short for the protocol and network known as InterPlanetary File System. Thanks for tuning in. We hope you enjoy the show.
Hey guys, so this panel is all about IPFS. IPFS is pretty much the technology everyone is using to decentralize their websites. It's not perfect, but it's what we got. And a lot of the guys on this panel are making it even more magical, and I'm pretty excited to hear what they have to say. In fact, this is Spawnet's panel, or he's the instigator for it, so I'd love to hear him seed the discussion. I assume you can talk about some things you're working on.
Yeah, sure. I want to talk a little bit about IPFS, so the use cases of IPFS beyond let's say the common use cases that almost all these dApps are using today, like just storing like avatar images or just hooking up some data on a blockchain using IPFS. So one of the sort of the contrarian ideas that I have around IPFS in combination with a blockchain is, if you look at a lot of applications on blockchain, a lot of these dApps, they often make like assumptions on zero trust in the whole system. And my observation, if you look at different apps, including the one we are building, is that that's not actually the case. So the use cases that you're building on top of it, so the actual use case, it's most of the time it has something. It has some sort of a touch point with the actual world where you interact with other people and you want to transact with other people. Where obviously you want to have like the distinguishment, I think, between like sort of the financial aspect where you transfer value from one person to the other. Of course, it has to be trustless, and you have to make sure that you cannot double spend your money and so forth. But on the other hand, I think there are plenty of use cases, and those are the ones I would like to talk about, maybe for starters. So use cases that I see where we could potentially use IPFS as some sort of extra layer on top of the blockchain that actually helps us interact with other people. So like get solutions for certain applications on blockchain, which actually don't require that zero trust aspect. So one of the examples I could start off with, and I would like to have your guys' opinion on that, is, for example, who knows the example of Peepets, the microblogging tool. So they intensively use IPFS to store their peeps, which is, for those who don't know it, it's a decentralized version of Twitter, where people can actually post their messages. So I attach some pictures to it, like this. Yeah. So attach that's much better. So they can attach their pictures to it and so forth. And then in a later stage, you can actually do a transaction to persist that on a blockchain. So what happens in the background is there's a centralized server, a website, that actually captures whatever you're typing in. It stores it for you on an IPFS server, and it puts the IPFS hash on the blockchain. Now, there are two situations, and that's, I think, a first good example. So you either can do the transaction yourself, and then you easily bump into all the current limitations of a blockchain system like Ethereum, like scaling. It's not possible for everybody to start microblogging on the same Ethereum chain. Secondly, is the transaction costs that are involved. You obviously don't want to pay for each tweet or each peep you send out. So there are a lot of practicalities that don't work in that situation. Now, the way that they've solved it, for example, is that you can actually send out that peep, the data that you create yourself. Instead of doing a transaction, you just cryptographically sign the payloads. So the IPFS hash that results from the peep you're sending and you're inserting in the system, you're signing that with your MetaMask. You're not actually doing a transaction. You're just signing the payload cryptographically. And then you're offering it to the website. And what they will do is, after some time, let's say after an hour, I don't know the exact periods, they will accumulate all these peeps, so all these payloads, including all the signatures, and they will upload it again. So that's accumulation of all these peeps. They will upload it again to IPFS, and then that specific hash, they will do a transaction on the blockchain to persist that. So that means that so that batch could either contain 1, 10, 100, or 1,000 peeps, or any amount, and it always results into the same amount of data in the transaction, being one IPFS hash. So you have like fixed costs on that because they do it on specific intervals. So it's like you can beforehand predict how much it's gonna cost. So that's the way it technically works. So what I would like to kickstart the discussion with is how important is the fact that you can actually do it like that, in the sense that I have the choice as a user at this point. If I find that peep that I'm sending out very valuable, I can still choose to do that transaction myself. And so I don't have to rely on a third party to do that for me. So I still have that option to do that. But if I'm okay with like waiting for someone else to do that transaction in a more efficient way, then that's okay for me, because those peeps might not all be as important or as valuable as another peep. So I'm willing to wait. So for me, that is one of the examples of the fact that even though you want to be sure that the data is genuine and nobody can prevent you for sending out tweets, or you're not censorable, that in this case IPFS can be a tool that allows us to like scale up that solution without having to do more transactions. So I don't know if you want to pitch in on that.
Yeah, I think it's interesting, this way of aggregating the data, so you don't really have to do one transaction for every tweet or peep or whatever the name it is. I just knew about people the other day, and I thought that actually using transactions to do your tweets, even if they are cheap or not, it's a big friction in the beginning for users. Even for me, that I wanted to use it. I think that it's an interesting way to overcome this initial friction with users. I mean, you still have to sign them, but yeah, I'm with you with that. It's a good way, an interesting point to decouple a little bit from the data on the chain.
Yes, I really think that those are extremely interesting possibilities. But to me, the big question always is like persistence, right? Will I be sure that what I sign and put on IPFS will still be there like the next day? So I maybe it's too soon to go into that. I don't know, but that to me is like the biggest issue right now. So.
Yeah, I know this is an IPFS presentation, but yesterday I spoke with a guy from Swarm, and he presented an idea to solve that problem that was very interesting. So let's say that he hosts some content that I want, and I access it through you. So I pay an insurance and deposit some money somewhere, saying that I want this. So if you want to claim this money, you have to prove that you are storing that. So when I request that to him, you will send a kind of a signed certificate of I own this piece of data to him, and he will send the certificate to me, saying I certify that you own that. If you go offline and I request this file, he will send me the certificate saying that he owns it, but he will not send me his certificate. So he's online, and he has to pay the price for not being online. Do you guys think that can work?
But this sounds more like a punishment to not host it's not like an incentive. But yeah. But how this will work with tweets that are like small pieces of data, you need to really like put some incentive to make them really available.
So, Spanette, maybe you can talk about this. Like, how is Peepit solving that now? Like, do they have like a IPFS persistence or?
No, so that's one of the issues currently. I think with PPET is that so their smart contract and all that's open. You can download the ABI, you can interface with it. So there are already alternative implementations for the front end and so forth. So that's a good thing. But obviously, yeah, there's no guarantee that the IPFS data is available. So that might also be like another topic we can talk later, how decentralized everything is, because if you look into practice, how most of these dApps are interacting with IPFS is again through Infura, and we talked in an earlier panel around centralization with Infura or with Etherscan, for example, as another example. So yeah, that is not really decentralized. You don't know what they're actually doing with the data that you leave behind on their systems. So that might be an issue. So decentralization, but I think that's another topic. But to answer your question, so they're currently not doing it. They're also using Infura.
So you're losing? Are people losing tweets?
Well, the thing is, it's a centralized solution anyway. So they say, okay, we don't have the ambition to be fully decentralized in the sense that they know, and they also say like it's an opinionated front end. So they will actually censor content if they deem that it's inappropriate or even illegal content that you would post on there. But then again, it will still be on the smart contract, so the IPFS hash will be available and so forth. But they maintain the right to sort of censor it. But okay, I'm not here to make the case for PPET. Obviously, it's more about the IPFS aspect. What we've done, because I just want to talk about like potential solutions or potential innovative ways of using IPFS as an add-on to the infrastructure we already have in place on the blockchain itself. So what we presented it last year on DEF CON was the IPFS spinning consortium, as we call it. So the idea is you have initiatives like Filecoin, for example, which sort of solves or which creates a whole market of an asymmetry in sharing and sharing data and needing data. So if you would, for example, host a Filecoin node, I would have to pay you for storing my data. So there's an incentive model. So I will pay you for storing that data. The reason I have to pay you is because I'm not returning a similar service. So I need some service from you that I'm not offering. The idea of the IPFS consortium or the pinning consortium would be that you can group yourselves together with people who donate the same amount of disk space to each other. So let's, for example, imagine it's the four of us would create a consortium. Then we would all pledge to host, let's say, 10 gigabytes of IPFS data for each other. And moreover, we've added a smart contract so on the blockchain for that. So when I want to add certain IPFS content, I could either hash by hash, but that's very inefficient, of course. I could also create like a manifest file of all hashes that I've created during a certain period. That can be like 1 hour or a day or even a week. It doesn't matter. The most important aspect is that I have like a list of stuff that I want to have replicated. So I want to have the certainty that my data will remain available. And I will post that hash or that hash from that manifest to that smart contract. And we all, the four of us, agree that we will read out that contract and run a small like daemon that's always listening to that specific contract, reads out a manifest file, and pins all these hashes to your own node. And as long as the four of us do that, we're sort of in symmetry. So we don't owe each other anything because I get as much service from all the peers in my consortium as I'm offering them. So it's some sort of an edge case of the idea of Filecoin, but it's much simpler to implement because you don't have to buy into a token or do transactions or keep accounting for that. So that's something we've set up, which we think is like an innovative way to actually use IPFS.
Yeah, I agree. I mean, it's like adding another layer on top of IPFS to achieve this pinment of content. And I think we should enforce this way of not monetizing contents. So every content has some kind of like the same value or democracy between them ourselves. And yeah, but yeah, this IPFS consortium at the end, it's something that we create in groups, and maybe it would create like islands of content not really like what IPFS was created in the first time. I don't know how you see this like new topology.
Sorry for interrupting, guys. I just wanted to ask, is it really a good idea to treat all data as equally valuable? Because sure, in reality, most of data is really useless, you know? I really doubt if that would be a really feasible approach to in general, so.
Yeah, but the thing is, so in the beginning I talked about like storing simple data like avatar images, for example, from of users that you have on your dApp. I could imagine that there are like 5 different dApps that have the same problem. So it's similar data. It's maybe not critical. So sort of the value of the data might be the same. And in that sense, that's more the use case, I think, for an IPFS consortium, not that to treat all data equally, because I agree with you that that's of course not the case. But the thing is, right now, all these dApps, they are all spinning up servers, which are in the most cases like centralized servers, or they're all stored on Amazon or on another cloud provider. And they're all hosting their own set of IPFS nodes. And so the problem is there with like either censorship resistance or just availability. If the project decides to stop their service or they run out of money, they cannot pay their service anymore, so they get taken down or they just expire for some reason. That you want the data still to be available. And that's sort of more like the collaboration, since everybody has to buy into some cloud service or use a dApp node, for example, with an IPFS node on that. They can, in an easy way, collaborate, so without having to set up and to sort of comply to rather complex rules. If you look at Filecoin, I'm not here to diss Filecoin or in any way, but I think the reality is that it's pretty difficult if you're already building an app and you're like creating your own token economy already, to add an extra layer of token incentives with another token on top of that. So in theory, that all works, of course, and that's nice that there are these initiatives. But I think it's a hard sell, and because it's so complex to implement, and that's why I think that there are, with some just trying to be creative with the technological components that are already there, but also added with the observation that some of the things that we assume that needs zero trust in that system are not actually the case. So in the example of IPFS consortium, for example, I cannot have the guarantee that the other peers in my consortium will actually perform that service. But the reality is that we have like trust relations with other projects, and we know that they have no incentive to screw us over, and it's just like, I'm helping you and you're helping me, so let's collaborate, so that the trust is is established in the real world, and it's not mission critical. So if I have the only problem that I would have is if all these participants would fail to actually replicate my data, and furthermore, if my own service would fail, only then my users have a problem. So it's not you understand. It's like you cannot guarantee the participation for everybody. In Filecoin, they solve it with a proof of replication, and what is it? The proof of space-time. So they all have algorithms to actually enforce that stuff, and then it's necessary to actually do that because you have this financial incentive, and you create all kind of attack vectors by creating a monetary system in there. So, but some of these things can, in my opinion, just be solved much easier. Yeah.
So I wanna share a specific case that we are dealing with. Some of us in our room are working with a project that's called Some City. How many of us have you heard about it? Yay! So it's an e-commerce platform, some sort of Wallapop for those in Spain or Craigslist for those in America, where you can sell and buy stuff. And essentially, anyone can create a marketplace, which essentially is a contract with a mapping where you post items and people want to buy, then you discuss the conditions and then you execute the transaction, and we have some resolution built in. But all these parts, we need to store critical information about the item, about the conversation, about the replies somewhere, and we are using IPFS. And I think this is a trap that a lot of projects fail, that you have one single IPFS node that you use, and you don't realize that that's not either persistent nor decentralized. You're just using a fancy database. So we are in a unique position because we have this structure of different marketplace of owned by one person who is incentivized to make this marketplace as useful as possible, to make people use it, because when people post an item, they pay a fee. So we can use this fee to say, okay, person that owns this contract, you created the contract, good job, but now you have to make sure that you create a bunch of nodes all over the world so your content is readily available everywhere. Otherwise, no one will use this platform and you would not earn your fees. So Filecoin, what they want to do is they want to use a file-by-file incentivization layer. And maybe we can find some middle ground approach where you use some broader concept, like the IPFS consortium. If we can tokenize somewhere 10 gigabytes and I pay you this much. So it's not as precise and maybe it's easier to implement.
I don't know, but I'm just asking if we could somehow enforce that the users of each app form a consortium themselves. So maybe not sharing everything, but just in a subsets or something like that. I don't know.
I mean, that's totally doable. It just depends on how you interpret these hashes. So you need to have a signaling mechanism how to propagate this. Now, in the current the current existing iteration of the IPFS consortium, that's done through a smart contract. Obviously, that's not the most ideal way to do it, because then still you're stuck with some gas cost at some point if you want to add something to it. It's also not so granular, because it's not feasible to do that transaction for each and every hash, of course, you want to add. So there's some sort of delay that's introduced there. But still, yeah, it just depends on how the implementation is done, and you can slice it up, that data, and have the most important thing is that you just want to have a certain assumption on the data availability. So it's not a hard guarantee, but the chances are much bigger if you have a consortium of 4 or 5 people, that you know that at each moment in time there will be at least one of these people that have actually done their task and are available at the moment that you need the data.
Yeah, I just came up with an idea. What if we use the IPFS PubSub app instead of a smart contract? So the idea will be, let's say that the 4 of us, we want to do a consortium. So we can all of us exchange our node identities or store that information in a contract. And then if you want to say to us, hey, ping this information to me, you just send a PubSub to all of us, and we should be online because that's our duty. And we should ping the content. At the same time, it's kind of a control that you can keep track. Oh, I pinged Abel and he was not online. Fuck you. And you can keep doing that, and at least you have some sort of idea of who's taking care of the node, who isn't. And you will avoid the fees. And I mean, PubSub is free and quick, so you can be as granular as you want.
Yeah, you're totally right. And I think in the end, you could just use the IPFS consortium to sort of store the different members. So each of us might have a key pair that we say, okay, this is our identity as a member of this specific consortium. And just to be clear, it's just like a consortium. You can spawn any number of consortia. It's not like it's one big pool where everybody has to participate in. No, you can have for one specific use case, let's say for our avatars alone, we can make a consortium, and maybe for more mission critical data, if we have some commonality that we say, okay, this could be a consortium where that type of data is stored and it's equally important for us. We could create a second consortium for that. So just to make that clear. But indeed, you could in the end use the consortium contract only to store the membership of whoever's there. And then you could use a PubSub mechanism. It could be indeed IPFS, the PubSub system, or even Swarm also has messaging possibilities to, or you could use Whisper or anything basically that allows you to do that PubSub and establish those links between the different parties. And then just use the cryptography to sign that data. So it's enough that I create a manifest and I actually create a digital signature. or a cryptographic signature of that data for you to be able to verify that I'm actually part of the consortium. It's not somebody else just pushing some random data or their own IPFS hashes on the same pub/sub channel. So that's totally doable, I think. Yeah. So on another note, so one of the big advantages which we can all take or use sort of in our own solutions is the fact that IPFS uses the content hashes. So once you have the hash and you have the data, you can verify the authenticity of the data. Also, maybe as a side remark, always if you use like the JavaScript implementation of the IPFS API, so if you read out data from an IPFS server, you must know that those modules, they don't verify the data. So it could very well be if you connect to an IPFS server and you request a hash, and it would be like a malicious IPFS server, they just could serve you other data and pretend that it's that hash. So there's of course a way to validate it, because you just have to recalculate the hash yourself, but it's just so that you know that out of the box these modules don't do that, so you should actually do that yourself.
Yeah, you're totally right. And for the library I use for DAppNode, I always check. So I download the file, and then there is a flag that you can use with the IPFS API, which is, I don't know exactly what it is, but like only hash. So you don't actually upload it, but it computes the hash and you get it, you check it, and then you can know, oh, something went wrong, or someone is trying to maliciously attack me.
Yeah, and if you look at the fact that you have this content hashing, it's very easy to granularly build up some sort of a hash tree. So you can store some data, for example, like another manifest of hashes or just JSON data or binary data, whatever. And you can include that data in like a second layer and a third layer and so forth. So there's a possibility to drill down. So if I give you the root hash of whatever data structure I want to present to you, you can like individually verify and drill down to each of these leaves in that or nodes in that whole tree. So you can verify everything. So in the end, if you take it to the extreme, and that's almost the place where like the concept of PeepIt is at right now, that they only use the blockchain as some sort of a notary service that adds a time aspect to that hash, because the hash itself represents like the content of the file. So that's a guarantee that you get from IPFS. The only thing you can make any assumptions on IPFS is when the data was created. So if you post it on a blockchain, then obviously you get a moment where you can say like the data hasn't been created later than a certain date, because like the date stamps of each block, it's public information, you cannot forge it. So that's one aspect. And then you can also do the other way around. You can say like in my payload, before I actually sign it, my IPFS payloads, you could, for example, also include a hash of a previous block on the blockchain. So if you just add a block number and you add the hash of that block, that specific block, and you include that in your payloads, then you can also make sure that, or you can prove to other people that that data hasn't been created before a certain date. So you don't even have to do a transaction on a blockchain to actually use that data in your IPFS payloads to prove that data hasn't been created before a certain block. So, I mean, that's also, again, a possibility without doing any fancy stuff, just using the fact that you have content hashing, the fact that you can cryptographically sign stuff in combination with the blockchain. To actually do much more than you would be able to do with just storing state and state transfers in a smart contract. And it's also a pattern. It's a known pattern which is called stateless contracts. And the idea there is that you actually don't store state inside of the contracts, because you see a lot of these dApps that actually, so they keep arrays of data or mappings or whatever, and so where there's a big cost associated with storing your data on the blockchain. But often your solution as a whole is it's a hybrid thing. So it has a blockchain component. It might have an IPFS component, but you can leverage those two together to create something that sort of represents the state, but isn't necessarily stored on a blockchain. So if you're in a situation where you create a smart contract that holds states and you create some function that actually can read out the function or read out that data, just for example to render it in your front end, I think there you can easily have an alternative to store all that data on IPFS and just do a transaction on the blockchain to actually persist that specific hash, because the broader solution will probably be a mix of reading stuff from a blockchain, and also reading stuff from IPFS and using that to actually render your UI sort of. And yeah, I just want to add also to that, that's if you do it in a stateless way, I've also seen implementations where you really go to the extreme of that, and like the most extreme form of that is that you just start creating empty functions in your smart contracts that just holds as one of the parameters of the function is the IPFS hash. And you just do a transaction, you call that function, but the function actually doesn't do anything, so it doesn't store anything, it doesn't even emit events or whatever. And then you're just annotating your IPFS hash as a function parameter, which then comes into this big log file, which basically a blockchain is. It's a state transition. You have called this function, but you don't have to store it anywhere, because like the front end, it can just like inspect the blockchain and listen for events that occur and like filter out events that go to a particular contract. And once you have that event and you can read out that transaction, you can figure out what the parameter was and what the value of that parameter was. So it's not even necessary to emit events. So you can do it really sort of to the extreme to do that. So maybe I'd like to know your opinion on how, in what scenarios you would store stuff on the blockchain, or do you think it's okay to have it on a like an alternative system like IPFS? Do you have any thoughts on that?
I saw an attendee on the left rocking a super dope IPFS t-shirt. You wanna come and add something to the talk? Come on, don't be shy. This is an open discussion. Come on. I think Griff that didn't present it, but this is a new format that we are experimenting. So this is not like the typical panel on the big guys. So if any of you guys really want to come down and express your opinion, you just go here, and we are a community. So
let me think. Yeah, let me think what I have to ask. So it's a question for the audience. Is that the format, or the question for everyone around? Okay, so one of the things that I'm really interested about, and I know that's not maybe one of the main sort of concerns of protocol labs, IPFS teams, whatever at the moment, but it's about anonymous communication. So that's something that I'm really, really interested about. And basically, being a DHT as it is, basically everyone has access to, or many people can actually have access to the initiator's requests. Basically, everyone around me, or if you're just like listening to the connections around in the DHT, you can actually get access to what am I as a node trying to access to, right? And I've seen like with libb2p should be quite easy to sort of add some sort of middle layer logic to even using onion routing outside, not with Tor, but even onion routing using other peers and whatnot. But that's something really interesting, and I don't know if anyone has any ideas about that. I'm sure it's something that can be added eventually in the protocol, or just as a middle layer or something like that.
I don't know. Yeah,
Okay.
for sure will be interesting. Yeah, my concern is about transferring huge chunks of data. How would work this onion routing in terms of performance? So maybe you have to choose and then put some kind of balance between what you want or what you have in terms of availability or privacy. So
maybe can you explain how the sort of the announcing system works? So if I add a file to my local IPFS instance, so it creates some peer connections, obviously, to other peers or to other nodes in the network. Yeah, how exactly does the routing mechanism know that that specific hash is hosted by myself? Because that might also raise some concerns about like the privacy of your data, because how can I like snoop in on to see what are you hosting on your node, for example?
Okay, so I think that's a very good question. one of the ways, so basically concerning performance, first of all, so really quickly, in my opinion, is you don't have to route things through Tor, right? So you can actually somehow pick random nodes within the DHT and then use those 3-4 nodes to build a circuit, which then you can encrypt the messages in a way that you're using onion encryption, route through them, and then the exit node can actually do the proper request. So then in that way, you can, it's still in the DHT, so without going out of like Tor, through any other communication protocol, or you can still have a quite nice way to use sort of an onion routing. The problem is to pick the 3 nodes that will build the circuit so that people around you will not understand that this is your exit node. And that's probably one of the main questions in this case. So basically, I guess in terms of I think that's one of the things with pinning, and maybe kind of correct me if I'm wrong. Anyone can correct me if I'm wrong. I think with pinning, the cool thing is that you only pin or you only store things that you want to, right? And I guess that's one of the ideas. So I guess the problem here would be exactly just protecting the initiator of the lookup, because for storing stuff, you know that whoever pins it explicitly. So you're fine with whatever you're pinning supposedly in your local disk. So I don't know.
I'd love to add some thoughts here. My name is Juan. I'm started the project, and this is a very important question. The notion of reader and writer privacy has a lot to do with how you find and how you advertise, find, retrieve, and serve content to other people, for and from other people. And right now, that in IPFS has been abstracted out into a layer we call content routing, which we use at DHT as one of the functions that you can use, right? So we are playing around with routing over PubSub as well, and routing over local sets of nodes. So for example, there's a hack, I believe PurePad is an application that uses the DHT only to find each other. And then after that, the content is not retrieved through the DHT. Once you find the set of parties, you connect directly to those, and then you can move the content between them. So strategies like that can help. Now, this is such a complicated thing because security and privacy are directly opposed to performance in this particular case. Not always, just in this case. And you end up in a situation where you want applications that feel really snappy and quick, and on the flip side, you want applications that where no party can see what you're requesting. So our way to navigate this is that we want to implement several points where policy can be added into the protocol, where, for example, you should be able to store stuff and not advertise it or distribute it to anybody. You should be able to request a lot of stuff to kind of hide your actual requests in the noise. You should be able to have a privacy-preserving content routing protocol, which is kind of what we're heading towards. But although that necessarily will have to be slower, especially if you want it to be global scale. A global scale privacy-preserving routing protocol for content is really hard to do, and really hard to make it have good performance. But that's something we are very interested in finding. I will give a few pointers for things to get involved in. One is the libp2p project, which, by the way, a lot of these questions are for libp2p as well. The libp2p project has an effort around DHT research of finding better constructions for new DHTs. One of the key questions there is, how do we make a privacy-preserving DHT? That'd be great to have that. Not clear. There are a lot of really good papers out there. IPFS right now is using an implementation of Karambia, which is one of the very first DHTs. There's a bunch of other DHTs that have been designed since that have better properties that we could implement if we wanted to. It's more of a question of really finding the right one before we sink a lot of effort into implementing a new one. But this is a space where a lot of people could get involved and to find what the right construction might be. And then the other thing is, DHTs are not the only routing protocol there could be, right? We could have a lot of very different content routing systems that move around data in different ways than a DHT, and that is, as well, is an effort. I don't think there's any groups right now trying to push on that, and it would be great to see more activity in that as a space. I think if you're very interested in this question, get involved on the libp2p project, because this is getting figured out there, and we're probably going to have a conference around libp2p sometime in 2019 where this will become a very important question, because we want to get to a privacy-preserving content routing system, but that is super hard. I will throw in there as well that OpenBazaar built a Tor transport. So right now, as a stopgap solution, you can put your entire IPFS node behind Tor, and then route all traffic like that. But that's still, you could do traffic analysis and all kinds of things to try and figure out kind of where you are. And there's a big question as is Tor safe? There's a whole bunch of questions there. So overall, like privacy preserving networks, really key, not solved at all. There's a lot of work to be done in that direction. So thanks for bringing it up.
Yeah. One thing I would like to ask, maybe you can ask, or I don't know. We tend to think about onion routing like the solution for these privacy problems. But maybe another approaches like I2P for peer-to-peer transactions could be better in this case, or for performance, I don't know.
There's a lot of problems that get a lot easier if you start thinking about them as moving around individual packets of requests instead of setting up a connection and then doing everything over that. That's potentially a promising direction. It's just really making a privacy preserving transport is super hard. I would point people towards things like Vuvuzela. There's a whole line of work around really making much safer round-based message protocols. And it would be amazing to just scale a massive packet switching thing that just has privacy preserving guarantees, because then you can bootstrap a lot of stuff on top of that. You can get a lot of networks that have maybe slightly worse performance guarantees, but because the underlying protocol that you use to find each other is safe, then that's fine, or roughly can be better than the current setup. Right now, like ISPs can see most of what everybody's doing, and it's pretty crazy.
Yeah, maybe I could add to that. So I was wondering, if you're like thinking about how you can like improve the protocols or the way IPFS works in its core, could you elaborate on till what level are you looking at? Because I could also add an extra layer so that I, for example, encrypt the data that's on IPFS, and in that case, I might be worried about people discovering who's hosting my data or how my data is routed throughout the network, because I know that it's encrypted data anyway. So are those also considerations you take into account?
Yeah, and we design a lot of IPFS with that in mind, where a lot of the layers are supposed to be pluggable and building block oriented, so that you could do things like encrypt things ahead of time before putting them in. Then you don't get the duplication, but that's fine. Like in many cases, privacy is more important than duplication. And so just in general, that'll be good. We have an effort around private content where we want to build the facilities for doing that encryption directly into the tooling, but that probably won't land for some time. A lot of this stuff is considerations that we have in roadmap, but they're rate limited by the bandwidth that we have to implement things and the community interest. So we try and direct a lot of our roadmaps based on real direct use cases that we hear about. And so if a lot of people care about some things and want them sooner, then participate in helping set that roadmap by voicing this stuff and through GitHub, by talking to the teams and so on. We want all of this to be as usable and useful to people as they want it to be, and to really treat it as building blocks where maybe IPFS can solve some part of the solution, can be part of the solution. Maybe it's like actually take apart the pieces. This is why we put libp2p and IPLD as separate projects. Or it could be that you could come up with a much better idea and like you contribute it to the project, and then it becomes like the main thing. So it's very, very, very open, and want to encourage everybody to participate.
You're the host, by the way. Yeah. You have to stay there. Can you talk a little bit about IPNS?
Yeah. Also, I'm gonna save self rate limit so that I don't like monopolize the conversation. I don't want to hijack the format, so I'm gonna get off here in like 2 minutes. So that way, I'm gonna answer this question and get off. IPNS, which is a name system for everybody, it's like the way that we do mutable pointers. That right now, we haven't worked as much on it as we want to, and it's really not performing well because of that. Turns out that this is a much harder problem than we originally anticipated. We already knew it was hard, and we said, okay, well, let's work on this later. It turns out to be even harder than we expected. We have a lot of really good ideas, but they're not implemented yet. So around this, where we're headed is, right now we have a couple of experiments. One is to route some of the IPNS requests through PubSub as well. So you could do naming over that. The major blocker so far on fixing IPNS was that because of that, we wanted to build a very flexible record routing system and then that led us into IPLD land. And so we're like still doing a bunch of that work, and then we're like coming back out of that. So that's sort of where we are in the finishing this work and then now coming back out of that. I would expect, I don't know for sure, I would expect IPNS to be split out into a separate set of tooling and components where we can play with a bunch of different types of solutions. Like, for example, it'd be great if the naming system would allow you to submit a name with very strong permanence guarantees so that you put the name on a blockchain, for example, like, say, on ENS or something like that. Or you had much faster guarantees, like, I want my name to be resolvable within milliseconds in a data center. That is very different. And so that you probably want to do over PubSub, but it might not be routable everywhere. So there's like this whole space of design in a naming system, and the goal of IPNS is to be pretty flexible to the use case, but it will be application dependent. So we have to figure out how to make that not crazily confusing, because if it doesn't have like same defaults that everybody can use, then it's going to be hard to understand and use. And so we're still figuring that out. So I would say get involved and help us make it better. All right, I'm going to get off now.
Yeah, this IPNS system, it's something that we are really excited to see happen, at least in our project in DAppNode. We always have to face with problems with the dynamic naming system, stuff like that. And yeah, I really envision this like tool set of IPFS, IPNS, maybe a private IPFS, all that working together and really providing us the centralized web without going to this some overcomes we have to do to really achieve through decentralization.
And now I'm going to make another question, and I'm going to leave. So I know that the next panel or whatever is going to happen here is about mesh networks. So I just wonder if there's anyone here on the mesh kind of ecosystem who has played with the IPFS, libp2p embedded in some sort of a small devices and meshing together networks and whatnot. So just wondering if there's anyone doing this. This is super cool. I know I'm leaving.
Well, I've been involved in mesh networks, but not combining it with IPFS. But yeah, I mean, yeah, like Kifinet, all these things working together with this layer on top, like it's IPFS. It's really interesting, and yeah, to see it happen.
One thing that hasn't been mentioned yet that our team particularly likes about IPFS is the built-in content distribution network capabilities of it. Those of you that aren't aware, CDNs are basically how these large-scale companies distribute data all around the world in more efficient ways. Companies like Cloudflare, Netflix throwing up $20,000 boxes all around the world that host their content locally in all of your cities is how they've basically got around the ISPs fighting with them consistently. There's built-in CDN capabilities through the caching of IPFS when it gets the content on a node. So the more people that are requesting content in an area, if there are more nodes in that area, it will naturally be able to propagate faster. So that's just a cool thing that we like about it.
Hi, I'm Molly. I work on the IPFS team. And on that topic, one of the things we've been talking a lot about and are super psyched about is thinking about the offline first implications of the stuff that's being built in IPFS land and the uses of this for things like distributed web apps where they actually ask for content locally first before going out to the network, syncing edits locally first, and empowering a set of use cases that kind of make our tools and internet work a lot better, more fault tolerantly. And so that's definitely, I agree with you. I think that's super cool and excited to push on making it a lot better. So if anyone's interested in offline first magic, happy to chat with more people about it.
Yeah, maybe on that topic, I could also introduce the topic of OrbitDB, for example, because I think they're doing also a great job in that regards. So I don't know if who's using OrbitDB or has done some experimentations with it already. I think it's certainly also worth looking at because it's also just builds up on top of the technology, in the sense that they define different formats, different types of use cases where you can add some sort of how you can work with like decentralized databases. So they, for example, a data type which is a log file, so you can just add data, and so we can query it sequentially. Say, give me the last 5 records of this type. But also very interesting, they have also a document format where you can just have like use cases for collaborative editing, for example. So they do automatic conflict resolving, so you never have like merge conflicts, those kind of things. So in the backend, they all use like the IPFS as a storage layer, but they just add some more logic to it. And that's also a very nice thing to see that this kind of tooling is being built to be able to leverage the technology to use that. And so I think there's a lot to gain from that whole combination. And I encourage everybody here to actually look at all these different pieces of that puzzle, just to find innovative ways of just of combining them into like whatever the problem is you're trying to solve. So don't try to stare only at the fact that you want to have a system with 0 assumptions and 0 assumptions on trust, for example, because often that's not really the case, and you can just solve it with all the existing tools that are already out there. And as I haven't really looked into it, but I believe that in OrbitDB, there's also the concept of offline. I don't know if it's offline first, but I'm pretty sure that I've already seen demos or examples that actually show that you can, for example, start editing or do collaborative editing on a document type. And then only later when you come online, you will sort of resolve all the, sort of the online syncing. I don't know if you...
I've seen I think early days stuff with the peer-to-peer chat where you pretty much had like 2 people who are chatting with each other offline entirely, and then maybe a third person would join the conversation and would like sync in the message history all offline first, which I thought was super cool, and definitely has like a lot of applications. If you're, say, in an offline space and you're trying to collaborate or communicate with the people around you and you're overloading the central external bandwidth tubes, that is definitely a really useful thing. So love the stuff they're doing.
Maybe another aspect in that whole mix of solutions is the fact that you can use the public the key pairs, so the public-private key pairs from in the scope that Ethereum uses them, so which are compatible with like the accounts and then doing transactions and all that in Ethereum. Not only to sign payloads, but also to encrypt payloads, and that might also be like another trick in your box. If you want to add encryption and do some validation on is that the correct person that has actually created and encrypted that data, that's also something you can use. So maybe I'm not telling any magic here, but I think the magic is just in that combination of readily available tools that you can use. I don't know if someone else has some observations on that.
I guess to add on to that, we've seen some cool projects in the Ethereum space where basically if you want to have secure conversations between 2 people, you basically encrypt your data with their public key, and that you can put it on a public network, but only that person will be able to decrypt it using their private key. I forget the name of the project, but that is an interesting application of that for encrypted chat.
Something we've been talking about that can do stuff like that, but maybe a little bit more performantly is to encrypt the data, but then encrypt it in a single way. So you have deduplication of that data, but then you encrypt like the encryption key using that person's private key. So then you can make many of those, and it's very small. So you're just encrypting a very small chunk of data, which is then used to encrypt the wider thing, which you can then deduplicate. So it does the same thing, except you don't have to have 6 copies of differently encrypted data for 6 different people. You encrypt the data once, you encrypt the tiny key for everyone. And so same thing, just maybe more efficient.
Yeah, there's for example, the proxy re-encryption. That's also like a concept where people can store encrypted data and then they can send it out to other people and without knowing the actual content of the data itself. There was also a talk time ago, and I think it's also relevant here in this discussion. I think it was Alex van Zande who presented something on like using one account per device. So if you want to have like content stored on different devices, that you have some sort of like a throwaway account that doesn't hold any value whatsoever. but you can sort of create accumulation of all these different accounts. And if you lose a device, instead of having a problem because you've lost some keys, you have just like maybe a contract or some storage, which actually lists up all these keys, and you can just swap out one key for the other. One of the small proof of concept that we've also recently made was exactly using that technique, not for when you lose your device, but just to create a very low point of entry for people to participate in something. It was a small voting application where you could actually just start participating in like upvoting and downvoting content, and it actually used just a key that was generated in the browser itself, and that key was then used to sign the data, and then later on created it created a JSON file out of it and put it on IPFS, and then exchanged the IPFS hash to propagate your votes, sort of. And so that was a very easy way to do it, because you didn't have to create an account, you didn't have to go through MetaMask to link an existing account, which maybe you don't want to use for that particular use case. And also people that don't use MetaMask, they might not be able to use that solution and so forth. But then we decided to sort of enhance that thing by actually linking that temporary account to an actual account, and also by just signing a message, not doing any transaction, so you could just start voting. But it's later on, if people want to incentivize other people to participate in that vote, they might give them a reward, like in some crypto tokens, for participating in that vote. But that's very difficult, of course, to manipulate, because you can just create any amount of accounts and just start voting left, right, and so forth. So it's not Sybil attack proof, sort of. So our solution there was to actually just link it with any of your accounts. So actually sign a message with an account that actually has some Ether on it, in this case, to sort of link that temporary account to your actual account. So you're in the whole scenario, you don't have to do a transaction to a blockchain. You're just signing messages and signing payloads using IPFS as a distribution mechanism. And only so you can do you can process the outcome of the votes all off chain, and then just give some sign data that allows you to extract some of that reward that you want to give out for participating in that vote, maybe pro rata to the quality of your vote, for example, and just give like a signature, like a signed message back to the user that actually created it. And they can then use, and that's, I think, the interesting combination, they can actually use that signature that the initiator of that particular vote created for you to withdraw money from a smart contract, because you can then use that cryptographical signature to actually do a transaction to a blockchain. So it might be more handy if I presented it on a PowerPoint slide, maybe, but yeah. No, but I mean, there are a lot of innovative ways, again, to just to combine all these different technologies. So that would be my pledge, to investigate that and be very critical about how zero trust your solution actually needs to be. Anybody else? Maybe some final thoughts?
So I heard you mentioning or talking about using keys to encrypt other keys, and we did just that with IPFS. It's funny, I didn't really think about the content deduplication. We're just using IPS as a data store, so it's just a matter of having it somewhere. And we chose IPFS because it was the most decentralized solution, at least potentially decentralizable solution. But we did just that, is that we generated asymmetric keys in the client and then had them create per medical case a symmetric key, which they would then encrypt and store as well. So when they wanted to share it with the doctor, they would re-encrypt that case key and be very small little re-encryption. But not only that, what was interesting is we found, using some JavaScript libraries, some of them are actually now optimized. If you use the async option on the function, it will actually use the JS crypto primitives in the browser, and it happens so fast. So it is possible to use basically hardware acceleration, which is really nice, because that means you can like encrypt images, in our case, medical case images, as well as a lot of metadata and text and all that stuff, which is really cool. But we're still running an IPFS node, and that's my kind of big question with Filecoin is, what are the incentivization mechanisms going to be? Because there's so many different ways to slice it. And actually, I recently read a really interesting Medium blog piece that was actually about BitTorrent and saying how trackers, how they were basically these little private sort of despots that would just, decide what your upload rate had to be in order to download. And so effectively, they were creating upload tokens that you could then redeem and download. And a mechanism like that, as well as tying in bounties for old content that you want to exist again, because when content sort of fades away and nobody's hosting it, there are no more seeders anymore. So you need some way to incentivize them to bring that back, or at least hopefully find that file. So and as well, it actually made me think of like Game of Thrones, because if we did want another season, perhaps we could put a bounty on that content, and that would then produce the content as well if it wasn't even made yet. But yeah, I would love to see or hear about any kind of potential thoughts around incentivization and anything that's going on there, because I feel like that's an area that's desperately needed. Everyone I've talked to in the space wants either to run an IPFS node or wants just to utilize it somehow. So it's kind of our open question. The encryption thing is just sort of it was kind of something we put together, and it'd be nice if there was an out-of-the-box solution, but what we found works. And actually, what you mentioned about using the Ethereum key is that is only a recent spec that's been put into place. Most of the Web3 clients don't yet seem to have that integrated, but there's someone working on that as far as I've heard, so that will be eventually integrated. Because what we have right now is, if you guys have ever heard of 1Password, which is a password manager, really fantastic. They have a white paper that's fascinating that completely details their encryption scheme. And we actually pulled in a lot of their technique, and we applied it ourselves, so that in the browser we have it generated a massive DES key, triple DES, and the user never has to see that. They have a little click save to PDF button. They store it on the hard drive or email it to themselves or what have you, and everything else just happens under the hood, which is great. But they still need that giant key. And if they could just use their Ethereum wallet, which they're already using anyway, like the encryption will only be as good as that. So why not just use that key? If that gets broken, then they're screwed anyway. So yeah, I'm actually really excited about seeing that spec eventually, because it'll make encryption to IPFS that much easier. So there'll be only one key to manage.
Yeah, well, actually, I have to sadly end this awesome panel, because this was a really great discussion, and let's give a round of applause.
Thanks for listening. If you haven't already, please subscribe and give us a rating or comment if you enjoyed this content. This episode was brought to you by Santa and the unicorns at giveth.io. Remember, this podcast is made possible by the donations we receive from listeners like you. If you'd like to help support the podcast, you can do so by donating Ether at dattpodcast.com. That's DATT podcast.com. Please check the show notes for more information. Thanks again for listening, and until next time, keep decentralizing all the things.
Decentralized. Decentralized.